Today, the second session is on the topic Big Data and Advanced Data Analysis and will be handled by Mr. Balaji Sekaran. Mr. Balaji Sekaran has about 20 years of industrial experience and has played key roles in technology, working with Fortune 500 clients. He has a vast experience in software architecture, design and implementation of large-scale projects, specifically on capital markets and banking. He has worked on large software product development along with cloud strategies. He is currently working as a senior technical architect at Accenture, Bangalore, and is working on architecting and implementing business process automation using robotic process automation, machine learning, and AI technologies. With immense pleasure, I welcome Mr. Balaji Sekaran for handling this session. Welcome, sir.
Thank you, sir. Yeah, I'm happy to be here. Thank you for giving me this opportunity to conduct this session. Today I'll be covering. Let me first share my screen. Let me know. Let's start seeing my screen. Okay, I started sharing my screen. Please let me know if you're able to see the screen.
Yeah, it's visible, sir.
Okay. 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 Covering the big data and the advanced data analytics. So like for today's agenda will be like, and these are the topics that we'll be covering as part of this training session, like what is big data and the characteristics of big data. What we'll talk a little bit about what is data analytics and like why are we actually going are the industries moving towards the data analytics presently, right? Like, and then like in a different types of data analytics. We'll also talk about the data analytics life cycle and a little bit about the business front, right? Like so business side, like so what is the return on investment on this big data projects, right? Like so in the industries, right? Like so we'll be covering that, and then data analytics project planning, right? Like so how the industries are planning, like so for starting from the discovery to maintenance, like how they plan the project. And then we'll cover a little bit about the machine learning. It's actually so machine learning is very closely coupled with data analytics. Like so we'll cover a little bit about that. And RPA in data analytics, like so RPA is robotics process automation. How these tools are helping in the data analytics. And like so finally we'll talk about big data opportunities, right? Like so for the students, right? Like so how they can utilize these technologies to improvise their scope of employment or whatever, right? Like so we'll talk about these topics today. Okay, please stop me if you have any questions. Okay, what is big data, right? Like so big data is nothing but a collection of huge amount of data. It could be any kind of format, right? And it's day by day it's like growing exponentially, right? Like so whatever data that we have currently that was generated, like probably for 99% of the data that we have today are generated in the past 4 years 5 years now, right? Like so so much of data is being generated, that's and how do we utilize this data, right? Like how do we make it useful, right? Like so the data is coming every day, but like how do we make it useful? That's about the big data, right? Like so, and there are different types of data. I mean, like so I'll give a few examples of like how these big data is generated, right? Like the sources that is coming from, right? Like so internet of things, social media. I mean these are we are seeing these kind of applications every day in our life, right? Like so internet of things and social media are generating a huge amount of data. So a couple of other examples, like so when a flight travels 30 minutes or an hour, like it generates about like 10 to 20 terabytes of data, right? Like so that much amount of data. Like social media, it's generating like 500 plus terabytes of data every day. So like so the data that is generated is huge, and also like so we require a lot of infrastructure to process this huge amount of data, and also store, like how do we store these data in a place, right? Like so in an infrastructure. So these are the key for the big data and the data analytics. Like we'll talk about the infrastructure, which will be the backbone and all those things, like in the next few slides, right? So per second, right, like so for every person on the earth, like so we see that, like 1.7 MB of data is being generated every second, right? Like so the and like so these data helps in multiple ways, right? Like so predictive, descriptive, these are some of the ways, like where we can utilize this data to make it useful for the business, right? Like it could be any kind of industry though, right? So how do we characteristics these are some of the characteristics of big data, right? Like so we can call this as 5 V's of big data, right? Like the velocity of data, velocity, the speed at which the data is being generated is very huge, right? Like so as I said, like so we have different source where these data are being generated, like it could be IoT device or multimedia or like videos. It is generating, the data is being generated at very high speed, right? And also the volume, like so the other V is the volume. The volume, like the volume that is generated is also very huge, as I said. you know um, um, Multiple zettabytes of data are generated every day, every hour, or every second, right? Like so across industries, that much of huge volume of data is also generated, and a variety of data. The data can be like structured, like so we can variety this data into different types, right? Like so there are different types of data, like so we can classify them as structured data, unstructured data, or even semi-structured data, right? Like so for example, structured data, these are the well labeled data. For example, like if we have an Excel sheet or something from the traditional database, where we have well defined names, right? Like so name, age, or address. These are some of the named labeled data types, right? Like so this is called the structured data. Unstructured data, example, like so the data that we are getting from a Google search, or coming from different sources, right? Like so IoT devices, these are unstructured data. Social media, all these are unstructured data. We don't know what kind of data, like so it's not structured, like even the videos or images. This is what the unstructured data is. And also, like we have the semi-structured data, right? Like so for example, like XML file, and also JSON objects, right? Like so these are widely used across industry. The applications that are built using I mean in the industries, right? Like so they are using this semi-structured data. So especially for transferring data from one application to the other, or one company to the other, they use this on semi-structured data, XML format or a JSON is also picking up these days, like so it's like widely used across industry applications, right? And the veracity of the data, right? Like how reliable this data is, right? So I mean, like we have the data, like how do we rely on it, right? Like so we'll have to trust, like the integrity of data is what, like so we will have to check, right? And also like the value of the data. So as I said, like so we have so much of data, how do we make it useful is so important, right? Like so especially the unstructured data, like we get plenty of data, like we how do we convert that into a structured format, and like how do we make this useful to the business, right? So that's about the value of the data. Any questions so far? Okay. Okay. So we'll talk a little bit about the data life cycle, right? Like so, as I said, like so we have different data, different data sets, right? Like so, so different data sets. It could be anything, right? Like so, videos, images, like Excel files, CSV files, or whatever. First, like those data will be collected into a and stored into a data warehouse, right? Like data warehouse is nothing but like, so where we can store multiple formats of data, right? Like, so any kind of data can be stored in the data warehouse. The multiple data stores will be contained in the data warehouse, right? So, and then like the next stage would be analyzing this data. Like, so generally, like, the data scientist will do this portion of work, right? Like, so that how do we create the data is what the data science, I mean, like data scientists will do, right? Like, and the data analyst will pick up from this place, right, from the data warehouse, where they will act on the existing data, right? Like, so the data analytics, like they will use the mathematical and the statistical functions on the data that is being collected. And then, like, so eventually this data has to be visualized by the business leaders, right? Like, so eventually, like for making decisions for their business, it has to be visualized. Generally, like, these business leaders, then they don't look into this the entire data, right? Like, so they will just look at graphs or pie chart or these kind of things, to take decisions. And it is very important, like, so we have a very good presentation of the data that is being analyzed, right? Like, so there are multiple tools that are available in the market. Some of the companies, right, like they build their own dashboards. One of the familiar tools that is widely used across the industry is Tableau. Tableau is a licensed version, and it's a bit expensive one too, right? Like, so it's a they cost about $100 per month, right? Like, it depends upon the type of client, right? But it's a very, very, very good tool, right? Like, so where it gives a lot of visualized tools to give more insight of the data that is being captured and analyzed, right? This is one of the tool that we have. Okay, this is about the data life cycle. Okay, this is all about the data, like, so that I wanted to talk today. Then we will move into the data analytics part, right? Like, so what is data analytics? The term data analytics refers to the process of examining data sets to draw some, some information, like what is there in the particular data set, right? Like, so there are multiple techniques that are available today, right? Like, to analyze the data, there are many, many techniques and then tools are available, softwares, tools, even the cloud services, like, so either it be Amazon Cloud or like, Google Cloud, or like there are multiple, they provide multiple services to perform this data analytics. And AWS is like, so is one of the leading market tool that is used across sectors for using for building, for implementing the data analytics projects. It has inbuilt services, like, so which we can, like, and also it helps us with the infrastructure and the data storage, the processing, data processing. AWS helps in a big way, right? Like, so many companies have started using this AWS technologies these days to implement the data analytics projects. Okay. So why are we doing it now, right? Like, so I mean, like, so when data is there for quite some time, so why are we getting why these companies are getting into the data analytics now, right? Like, so um, as I said, like, so we need some kind of infrastructure in place to perform this huge amount of data, right? Like, so some of them are these are considered the backbone of any kind of data analytics, right? Like, so without the infrastructure in place, we cannot perform any data processing or data storage or the algorithms. And also obviously, like, so the companies should invest on these, right? Like, so that they get some kind of return on their investment, right? Like, so now we are seeing a huge amount of money is being invested into these kind of projects, right? Data analytics projects, whatever sector it may be, like, so they started investing in this, right? Like, so in order to be relevant in their business, they started investing huge amount of money for data analysis. For high performance computing, obviously, so that we need some kind of infrastructure to process this data, and storage. Like when we say storage, like we'll cover these two topics today, right? High performance computing, how the infrastructure is being set up. And also we'll talk a little bit about the storage management, which what are all the different storage management that is available, right? So these two things like we will cover. And also so we'll have better algorithms, right? So better algorithms, or even some kind of libraries to handle the data analysis. There are multiple inbuilt libraries, different from different programming languages, like which we'll cover in a bit, right? So we'll talk about those things now. Any questions? Okay. Okay. So, so the as I said, so we cannot perform these kind of processing, data processing in the traditional infrastructure. And also so taking a backup, or even the disaster recovery, right? All those things like was very difficult earlier, so traditionally, so if you have to provision a server, right? So database server or whatever, procuring from procuring to provisioning into the data center, it takes about a month or so. That is a huge amount of time, right? The business cannot wait, right? So they will have to worry about the time to market, right? And also the and also the infrastructure those days couldn't handle these kind of data, this amount of data that is generated. Now we have multiple companies like AWS, like in IBM, where they have this cloud environment, clustered high performance clustering environments, right? So all these are different nodes which are clustered together, right? And also the other thing is so these hardware infrastructure these days have inbuilt software programs or algorithms, to run the to process the data, right? So early it intelligently work on which cluster or which node it has to run, or it can also run parallelly, so parallel processing is very important in this huge amount of data processing, right? So these algorithms take care of it, right? So traditionally it wasn't there, right? We just have so much of terabytes of data, like memory or whatever, on the SAN storage we have. Traditionally we used to have this SAN storage, right? SAN is like a storage area network, where we mount it on the boxes, Unix boxes, and it was really difficult to handle, right? So now, since all these cloud platforms are in place, it's very easy to scale up and scale down, and the algorithms also take care of take care of the parallel processing. So the processing will be complete, very high. I mean, the processing can be done at a very high speed, right? This is actually one of the key factor why data analysis is picking up now, right? And also the data storage is also one of the important topic, right? So which we have multiple storage techniques, right? So in memory database, um, and then so cloud AWS has multiple services, so where the data can be stored, and no SQL database, right? No SQL, in the unstructured data, these are so for example MongoDB is a no SQL database, right? So where we can store the unstructured data, either it be video or the social media chat or whatever, and the cloud storages. In AWS we have they actually provide implementation for six different databases, like Oracle, MS SQL, and Postgres. These are some of the databases where they provide services. And also, like, so we'll have to talk about the security and the privacy, right? Like, so for example, if you're implementing these kind of data analytics projects for banking client, right? Like, so where the data is like where the data has to be stored in a very secured way, right? Like, so it has to be secured in a virtual private cloud, or even in a secured, I mean, like some of the banks, they have their own infrastructure or the cloud platform to handle it. If it is mounted on a public cloud, so this all the security features is also one of the key factors that has to be taken care. So for example, right, like, so the European Union, right, like, so they don't want to keep their data outside of the European Union, right? Like, so those are also some of the criterias, like where the big banks are, are the government organization put in place. Another example is like, Japan, right? Like, so Japan, whatever data that they wanted to store or their country's data, it shouldn't be going out of the country, right? Like that kind of things are being handled for different industries, right? So that should also be taken care. In-memory database is one of the fast growing database, like, so where because of the cheap memory cost these days, right? Like the entire memory or that entire data can be stored on the primary memory, right? Like entire data, right? So the accessibility will be fast, like, so the input and output will be very fast. There are some examples: SAP HANA and SQL Fire. These are in-memory database, and again, like, it depends upon the uh, type of applications, right? Like, so it could be little expensive when compared to others, but again, like, so if the application is very critical, the in-memory database can be used, and there is a limitation on the size of the data that can be kept on the in-memory databases, right? So this is about the data storage management. And also, like, so we will talk a little bit about disaster recovery, right? Like, so when we say so much of data is being stored, right? Like, so obviously, like, so the data has to be backed up every day. Nowadays, like with the cloud, they take near real time data, right? Like it is being backed up, and the latency is like very very minimal, right? Like, so, and they have different regions, right? Like, so the data can be kept in different regions. So for example, if a server in Europe comes down, the similar that the data can be recovered, that recovered from the Asia server or the America server, right? So that kind of infrastructure that we have for data storage, right? So these two things like acts as the backbone of data analytics projects. Any questions? Okay. Okay. So we'll talk about the types of data analytics, right? Like, so we can broadly classify the types of data analytics into four different areas. One is the descriptive, right? Like, so descriptive is nothing but what is happening in my business. Like, what I mean, like, that kind of that is what the type of analysis that we are going to do, which will be very comprehensive. Like, the data that or the information should be very comprehensive, and effective visualization, like this data should be visualized very well what is happening, so that the business leaders can take decisions. Why is it happening is diagnostics, right? Like, so why is it happening, to drill down the root cause of it, right? Like, so these kind of analysis can be done in this particular area. Why is it happening? And predictive, like predictive is widely used across industries, right? Like, so what is going to happen, what is likely to happen. So for example, like, there is a trade settlement system, right? So the trade has to be settled, trade has to be settled in T+2 in 2 days time, right? Like, so sometimes, like, there are different reasons like why the trade can fail. So, like, so for the projects, the big companies or the big banks, and when they fail, right? Like, so there is a huge financial impact to the bank, right? Like, so if the trade fails, and especially if a high value trade is failing, the financial impact will be huge. So based on the historical data, right, like historical data, the patterns, we can easily predict, like using this data analytics techniques, so whether the trade is going to fail or not. And based on that, like, they can take a corrective action, and go to the counterparty, or like, the banks, like in the trading parties, like, so well in advance, so that trade can be settled within the time frame, right? Like, so it is widely used not just in the banking industry, across industries, healthcare, or like, manufacturing, or all these industries. Like, predictive is one of the widely used techniques these days. And perspective, what do I need to do, right? Like, so what are all the corrective actions in case an scenario occurs, or do I have the exact strategy to overcome it, right? So what do I do, like when I come across that kind of situation, right? That is what, like, the perspective is data type, but perspective data analytics is going to talk about. Okay. So this is about the different types of data analytics. Okay, we'll just move on to the next topic, data analytics life cycle, right? Like, so how do we, how the cycle goes, right? Like, how the process goes, right? Like, identification of the problem, right? Like, so obviously, like, we'll have to identify a business problem, right? Like, so, and how do we formulate, like, how do we actually collect the data, or like, so plan, right? Like, so when we know what is the problem, how do we plan, and how do we formalize, is the second stage, right? Like, so, and then third stage would be the collection of the data, right? Like, so what kind of data that is which will be done by the data scientists, right? Like, so what kind of data that needs to be collected to predict, or like, come up with some kind of value addition, right? Like, so that is the stage, like, where what we do in data collection, right? And the next one is the data exploration and the preparation, right? Like, so whatever data that is will be in the raw form, right? Like, so we'll have to come up with some kind of preparation, right? Like, so the data what we collect could be multiple, right? Like, so for example, if we collect 100 different types of data, for the particular problem solving, like, we don't need so much, like probably we will need 5 or 15 fields, 10 or 15 fields, right? So that is what, like, the data exploration and the preparation will do, right? Whatever data is required, then we will actually prepare. And then, like, model, right? Like, so building a model, right? Like, so once the model is built, that can be used for analyzing, or like even machine learning can use these models to build some predictive analysis using the machine learning technologies. Eventually, the model that we create has to be validated using the test data, right? Ideally, like, so there will be two different types of data when we create the model, like, so which is we'll talk in the machine learning topic, testing data, and sorry, training data, and the testing data. These two data, like 80% of the data will be the training data generally, and then 20% of data that we collect, we use it for testing, right? Like, so testing or evaluate the data if it is correct, or like, we'll actually find the integrity of the data, right? That is what we do in the validation and evaluation. And this is the same, right? Like, so I think, like, I covered this part. Okay, obviously, like, so there will be some benefits, like, so when we are doing, when we go for this kind of data analytics, like, what are all the different benefits that we achieve, from a business perspective, right? Like, so it is very critical. The companies are investing on this, right? Like, so otherwise, in order to be relevant in the business, like, the companies has to invest in this kind of projects, right? Like, otherwise they're like, they won't be relevant in the business and they might go out of business over a period of time. So every other company, right, like our Fortune 500 company, even smaller companies, startup companies, they will have to invest in these kind of new technologies, so that they benefit out of it, right? Like, so improve decision making, right? Like, this is one of the benefit, right? Like, so based on the outcome, the senior leadership can make decisions rightly at the right time, right? And effective marketing, right? Like, so generally, um, with the data, the analysis that we have done, like, so we can do a better marketing, so that like our products are reaching the people in a more effective way, right? Like, so the traditionally, like, we don't do this, like, so for, I mean, we are seeing this kind of marketing analysis on a day-to-day basis, right? Like, so for example, um, we might be seeing in our like online stores, right? Like, so Amazon or Flipkart, based on your historical searches or whatever, you will be seeing, they will be recommending, okay, these are um, some of the things, like, so which you can buy, right? They recommend, if you buy something, obviously they will recommend some other additional product. So these are like, where is it coming from? These are coming from the data analysis, like, so historical search is what the coming from, right? Like, so, and they use some analytical techniques or the machine learning techniques to give a better marketing strategy, right? And better customer service, obviously, like, obviously, like, so we'll have to provide a better service to the customer, so where the data analytics helps and more efficient operations, right? Like, so there will be multiple processes in an organization, right? Like, so in order to streamline their process or save money or increase their revenue, and improved operations, all these analysis can be utilized, so that they can improve on the operation side, right? So these are some of the benefits, like, where the data analytics will help. Okay. Okay. So return on investment, right? Like, so obviously, like, when a project or when a company invest on these data analytics, like, or the big data projects. So how do we measure, right? Like, so in terms of revenue or whatever, right? Like, so these are some of the tangible ways to measure your return on investment. Effect on cost or revenue. Is the big data resulting in your revenue growth or any cost savings is being done? Obviously, like, why do we invest, like, so I mean, like, obviously it has to generate some revenue, and also like any cost savings, like, so based on some prediction, like we take the right decision, like, so this is what, like, the business will see. Any company that is investing on these projects, like, first they will check what is my return on investment. The business leader will first, my first question is, am I going to see any money, cost savings or revenue growth, right? Like, so that is one of the key factors, right? Like, that the business is going to see. And competitive edge, as I said, right? Like, so if we don't invest in these kind of project, we'll go out of business. Like, so we'll have to obviously differentiate from our competitors, right? Like, so say for example, like, so when a company, for a big company, right, like Accenture or like, IBM, when a client comes in, like, they will showcase these kind of projects, like data analytics projects, machine learning projects, like, that acts as a selling point for them, right? Like, so we'll differentiate from the competitors, right? Like, this is how, like, these are the new technologies or the tools that we have created, So so that the business comes to us, right? So competitive edge from the customer and team efficiency, right? Like, are we gaining any kind of uh, efficiency from a people perspective, right? So any improvement can be done in their workplace. These kind of things has to be measured, right? Like, so, and also speed to value, right? Like, so resulting in delivering faster. How fast we move to the market and what kind of value that is being generated when we implement these kind of project is what the business will look at. um, right, like, so this is about the return on investment. Okay. So like, so every other company or every other organization are investing in big data and analytics or machine learning, AI, and all those things, right? Like, so this is actually a prediction of what will be the revenue growth, right? Like, so over a period of 6 to 7 years now, right? Like, so they're expecting to have currently, like, so we are seeing around 56% of $56 billion being invested for this big data and analytics, right? Like, so in the next 5 to 6 years, like, so we are expecting to see more than $100 billion being invested. And then, like, so when I say revenue growth, right, like, so it could be anything, like, even the infrastructure the company is spending, the softwares that the company is spending, and also and the maintenance, right? Like, obviously when we have these kind of tools, it has to be maintained, like, so it requires some resources, like who has to maintain this, like all these things will come under the revenue, right? Under the company's revenue, right? Like, they're expecting to have a huge increase in the revenue for this data analytics in the next couple of years, right? Like, so it's which is going to double. Okay. So these are some of the languages, like, so which is widely used across industries for implementing the data analytics projects, right? Like, so Python has multiple. This is leading the marketplace, I would say, right? Like, so across industries or across companies, like, Python is being used, and it's an open source. It has about 70,000 plus libraries, like, to handle these kind of things, right? Like, so few, to name it a few, like NumPy, Pandas, Scikit. Um, so TensorFlow is a deep learning that is provided by the Google, right? Like, so machine learning technologies, and NLP. Python has multiple libraries, like, so which can be utilized for data analytics projects, right? And again, like, as I said, like, it's widely used, like almost 80% of the projects are the industry uses Python to implement these kind of projects. And again, like, this is an open source. There are multiple other projects, like, so, but those are licensed versions, right? Like, so come in, maybe very few clients might be interested in spending those licensed versions. um, AWS has a very good analytical tool, right? Like, but still it's a license, we'll have to pay for it, right? Like, so people are a little skeptical about investing, or it depends upon the client, like, um, if they don't want to invest too much, then they would go for Python. And JavaScript and Hadoop is one of the key framework, which is also used. Hadoop, like, there are different technologies along with it, like Hive. These kind of technologies are being used for data analytics projects, right? And R is also another one, right? Like R and Scala is also one of the programming languages which is used in data analytics projects. Initially, it was designed to resolve the issues in Java, but it has multiple implementations for a concurrent and then synchronized processing. So it depends upon the type of analytics that they wanted to perform. Like, so the architect would design, like, so which technology or which libraries should be used. So during the analysis phase, right? Like, so they will decide on which software they should use. But as I said, like across board, like, Python is leading the industry now. Any questions?
Any questions from the participant side?
Okay. Okay. So this is actually the project life cycle, right? Like, so
Hello,
project
sir.
planning. So yeah. Yes.
Sir, sorry for the reply. Sir,
Yeah.
we are using R language, SPSS language, I mean SPSS software, Minitab. So many statistical analysis tools are there, sir.
Yeah. There are multiple tools.
So
Like,
in
and
that,
these are, if you
how
name.
can we select the best tool?
See, it depends upon the type of project. Like, so obviously the an architect will decide on. See, as I said, right? Like, so concurrent processing and synchronized processing, Scala has better libraries, right? So if somebody wanted to use that kind of implementation, they would go for Scala. If they wanted to use, like, so some spreadsheet reading or CSV file reading, they would go for Python has very good libraries in it, right? And also like machine learning technologies, like, Python has different good libraries. It depends upon type of the project, like what you wanted to implement, right? Based on that, the before we start a project, right? Like, so during the analysis phase, right? Like, so we will design, or the I mean we the architect will design, okay, this is what the business is expecting. So for this, like, we have better libraries in this particular technology, and based on that, like, we will choose the technology. So generally what happens in real time, right? Like in real time projects, they'll have a comparison, right? Like, we today we are seeing four different technologies, like programming languages. They will come out with a presentation, right? Like, so these are the plus points and these are the minus points in these technologies, like the pros and cons on these technologies. And based on the business requirement on that particular use case, they will decide which one they wanted to choose. Did I answer your question?
Oh, yeah, yes, sir. Okay.
Yeah, the voice is breaking actually. Okay. This is actually one of the key things, right? Like, so when architecting a project, it's a very good question though, right? Like, so every project will do this analysis before starting the project, right? Like, so they will come up with some pros and cons, and they will showcase it with the architect team, and then like they will decide which one they wanted to choose. Okay. Uh, okay, this is actually the project plan, right? Like, so how would we, if we are developing a data analytics project, like, so this would be the project plan. First, it has to be discovered, right? Like the use case has to be identified, the problem statement. So this is, I would consider this as a very key stage, right? Like, so any kind of industry, right? Like, so the technology people will be separate, and then the operations or the business people will be separate. There will be some kind of disconnect, right? Like, so especially in these kind of things, there needs to be a very close coordination between each other, right? Like the business and the technology. the technology people will not understand the business, and the business people will not understand the technology. And obviously, to identify like with the use case, right? Like, so we need to have different workshop sessions being conducted with the business people. So that is ideally what is happening in the industry, right? So especially in the data analytics projects, and what we do is like, so we go to the business team and like, so we present with some use cases or some examples. This is what the technology can do, right? So we provide multiple workshop sessions to them, and then based on that they will come out with some ideas, right? Like, so okay, this use case or this business process can be utilized for data analytics, right? Like, so this is one of the key phase in the project, right? So once we identify the use case, like, so we'll have to do an analysis, right? Like, so it could be a business analysis, like, and also a functional I mean like IT analysis, right? Like, so technically whatever business case that they are giving, like, we'll have to check like if it is feasible to do, right? Like, so sometimes, like, so it may not be possible. When obviously it will, like, so identifying the business problem is the key, right? Like, so we have enough technologies, and then we have enough of infrastructure and enough of skills to implement that project. Discovery is the key, I would say, right? Once that is done, like, so, and also design, like, so we'll have a functional design created, functional design document, and also the technical design document, right? Like, so whatever implementation that has to be, we'll have to create a technical design document which the developers will use to build the project, right? And then the next stage would be the build, right? Like, where we actually code, right? Like, so the programmers or the developers will code based on the design that is being provided by the designer, right? Like, so in the previous stage, right? Like, so once we done, generally they will perform a unit testing on each of the components that is being built. And the test team, like, so there are multiple test scenarios. They will first create the test cases, test planning, and everything will be done by the test team, right? Like, so whatever analysis project that has been implemented, it has to be tested multiple times, or perform regression tests before it is being deployed into the production environment. Deployment is like nothing but deploying it into the production. Like, obviously this has to be in production, right? Like, so there are multiple techniques, right? Like, how do we deploy, and where do we deploy, on what infrastructure, on what type of project, right? Like, so generally the architect will give suggestions, or even the deployment strategies will be planned during the initial phase itself, right? Like, so and today the industry use multiple automation techniques to deploy, right? Like, so there are multiple tools, example Jenkins, Nexus is a repository though, right? Like, so um, the GitHub, like, so there is a separate concept called DevOps, right? Like, so where there is a continuous integration happening. This is one of the new technology, right? Like, or the new concept, I would say. It's not a technology, new concept, like where the software that is being built will be continuously deployed into the pre-production environment, so that, like, when we move into production, we don't see any kind of hitches at the last minute, right? So these are some of the technologies or the concepts, like, which are widely used these days, DevOps, right? And that is actually a separate topic though. And finally it comes to the maintenance phase, right? Like, so obviously whatever software that is built, so we'll have to have some maintenance provider, right? Like, so we'll have a support people who is maintaining that, and also change requests might come, right? Like, so enhancements might come. All those comes under the maintenance phase. Okay, this is about the data analytics project planning and the life cycle. Okay, so we'll talk a little bit about the machine learning technologies, like so as I said, so this is also closely coupled with the data analytics. These days, like for predicting, they use the machine learning technologies. Most of the predicting is used by machine learning libraries, right? Like so, machine learning. A quick overview on the history, right? Like it was coined, the term was coined in the year 1959 by Arthur Samuel. He is the person like who termed this machine learning word itself, right? Like so, so there is a huge uh, or the very significant advancement that has happened in the recent past, just because of the data, the huge amount of data that is currently being available, right? Like so, generally, these machine learning techniques use the historical data and the current data, and also the future data, right? Like so, whatever is going to come, right? Like the that is what is so important for implementing machine learning. So what is machine learning? Machine learning actually it's a subset of artificial intelligence. There are multiple techniques in artificial intelligence, and machine learning is one of them, which is very widely used in data analytics projects, right? Like so, it's actually the ability of the computers or the machines to automatically learn based on the historical data, right? And make some patterns, right? Like, and then without any human intervention, right? Like so there are multiple types of machine learning techniques. We will talk about that, right? Like so generally, so it's all about machine learning. It's all about making the machines learn by itself based on the historical data, and also with the data that is going to come in, right? Like so it could be any source, right? Like so IoT or multimedia, sorry, social media, or cloud data, like whatever it is, right? Like so it's about learning, making the machine learn by itself. This is what a quick overview of the machine learning techniques. So machine learning, so these are broadly classified as supervised learning, unsupervised learning, and then reinforcement learning. I would say like generally, they will use a supervised learning for the predictive analysis, but again it depends upon the type of project though, right? Like so supervised learning is like where um, you know done actually, which where we have a structured data, right? Like structured, or we have a labeled data, I would say, right? Like so we have some kind of defined labels. So let's say like we have 15 data 15 day fields that we have. So we know that we are going to get all 15 fields. So though if we have to do the machine learning using that data, so we go for supervised learning, and there are some algorithms available which are available for the supervised learning. That is what supervised learning is. Unsupervised is so we uh, there is no labeled data, right? Like so the machine has to learn by itself, right? Like so we'll have to, they will actually cluster the data that is being, they analyze the data. For example, social media, so whatever data that is going to come in, right? Like we don't know what type of data is going to come in, so it could be anything, right? So the machine, we cannot make the machine learn initially, right? But in case of supervised learning, we teach the machine or train the machine, this is what it's going to come. But in case of unsupervised, we just collect the data and then start, the machine will learn from experience, right? So, and then reinforcement learning, so very rarely used, but supervised and unsupervised learning, these two technologies, algorithms are like widely used, right? um, okay. Okay, these are some of the applications, right? Like so again, supervised learning can be still broadly classified into two types. Like one is classification and regression. So for example, these are some of the examples, right? Like so weather forecasting, market forecasting, population growth prediction, where regression type of algorithms can be used, right? Like, in case of classification, image classification, customer retention, these are examples, use case in examples for classification algorithms, right? Like unsupervised, again, that can be classified into two, um, dimensional reduction and clustering, right? Like clustering is like widely used across data, and dimensionally, like, so if we wanted to utilize, I mean, like, so if we have more visualization kind of technique, process, then we go for this kind of algorithms, right? Like, so these are some of the machine learning applications and their type of implementations. Okay, this is how we train the model. This is one of the machine learning model training. So the data coming from various sources will be initially stored in the database or the data warehouse or whatever it is. Different data sets. It could be any kind of data sets. So that particular data will be training the machine. Like as I said earlier, like, so the generally, like, the data will be classified into two. One is the training data and the other one is the test data, right? So training data, like 80% of the data will be used to train the machine, right? Like, so, and then the once the model is created, like, so we will, or once the machine is trained, like we will actually test the data based on the test data that which we had collected. Once it is done, like, so we will create the model. Once the model is created, we will actually use the machine learning algorithms, right? Like, so, and then, like, so come out with some outcomes, right? Like, so which can be utilized by the business to to direct their business to make some decision. So this is how the machine learning model training model works. Okay. Uh, so we'll talk a little bit about like how RPA is helping in data analytics projects, right? Like, so, so what is RPA? Like, so maybe before that, like we'll see like what is RPA. So RPA is like robotics process automation. This is one of the technologies which is widely used across industry for automating the business processes, right? So it is actually software robot, not a hardware robot like what we see in the manufacturing industry. Right? Generally, people misunderstand that this is a actual physical robot. So these are software robots, right? Like, so, which emulate the human actions, right? Like, so whatever the human does, like, so for example, there is an application, the user go and navigate the application from go to the file and open a menu and then download a file, um, and download a file. If it is an Excel file, the filter based on the Excel condition, I mean, business conditions, these are done manually today, right? Like, so, so in order to automate all these things, right? Like, so this robotics process automation helps. There are multiple softwares that are available in the industry today, right? Like, so these are widely used softwares. So Blue Prism, UiPath, Automation Anywhere, Pega. There are n number of softwares, but these are very familiar. I mean, familiar tools are the leading tools that is used across industries. Blue Prism and UiPath are very expensive tools, though. It's about like $7,000, $8,000 per year they charge. Right, like, so the business will have to check, like, so if they can take so much of if they invest so much, like, will they are they going to get any return, is what they will have to check. Comparatively, Automation Anywhere is like cheaper. It's like, in the ratio of 1:7, right? Like, so it's about like $1,000 per year is what they charge. But UiPath and Blue Prism are really expensive tools. Okay. And how does it helps, right? Like, so in data analytics, so RPA has multiple integration components, right? Like, so it has multiple, we call it as VBOs, right? Like, so VBOs, these are inbuilt VBOs, right? Like, so, one good thing about this RPA tools are like, so now everyone can do it. Even a business person can do it. Not necessary we should know some kind of technology or the programming language. These tools come up with a lot of inbuilt functions, so that like just from a drag and drop, this can be utilized. So that is how it helps very useful in data analytics kind of projects. Obviously the business people also can utilize these tools, um, you know to come up with some kind of reporting or analysis tools, analytical functions. They can utilize this. So that is where this RPA will come into picture in data analytics. It helps a lot. Like, there are some libraries, integration points that Blue Prism UiPath they had provided these days, right? Like, so they provide integration points for other functions also. Machine learning, AI, and data analytics is one of them, right? Like, so obviously, like very complex, if it is very complex analysis, there will be some kind of custom coding, right? Like, so basic analysis can be done without any kind of coding, right? Like, so it depends upon the type of project, right? Like, so if there is any less complex, they will the business they themselves can utilize this tool to create with some kind of analytics, right? Like, so these are some of the benefits, right? Like, so reduction of errors, decreasing cost, and improving the efficiency. These are some of the benefits that we are going to see using the RPA for data analytics. Okay, so this is about like so what is the benefit of RPA though, right? Like, so this is eventually it will help in data analytics too. Faster benefit realization, minimal investment. I mean, like, I mean, it's not right thing, right? Like, obviously we'll have to invest for the infrastructure and the software, right? Like, so but it's very minimal, right? And you know no disruption to the existing system. That is one of the key things, like why RPA is used these days, right? Like, so we don't have to write anything from the scratch. From the existing systems only we can create the analytics part, right? Led by the business and the with the support from IT, right? Highly scalable, right? Like, so these are highly scalable. Like, whenever we want, when there is a huge increase in volume, these can be easily scaled up, right? Like, so that is where the RPA tools can help these data analytics projects. So benefits of RPA: better accuracy, improved compliance, faster cost savings. Like, we can realize the return on investment. Scalable, as I said, like so increase productivity and the speed. These are some of the benefits of RPA. Okay. I think like so I pretty much covered like so we will actually talk about some of the opportunities, big data opportunities. There are multiple opportunities for the students like in this particular area, right? Like, so big data is used across industries, right? Like, so it is used in every other industry, and banking is one of the industry like which is widely using, like 43% it's used, right, in the banking, right? Like manufacturing, energy, every sector is using these kind of analytics and big data projects, right? Like, so implementing these kind of projects. So there is a huge scope for the students, right? So these are some of the benefits, like soaring demand for analytics professionals, and getting the right skill are difficult these days, right? So the people come out, like they might not be trained on these particular technologies. Even when a student is hired into a company, generally they don't train on these latest technologies these days. Generally they will go for database or like Oracle, or that is how they group, like Java. On a very high level is what their initial trainings will be in the corporates, right? when they get into the projects only, they will start learning all these new technologies. But it will be benefit if the students can start learning from the college itself, right? Like so they can be like so well trained when they can be really productive from day one of their project as allocation, right? Like so there's a huge opportunity on these big data and analytics type of roles. And like so they give a top priority. In many organizations give a high priority for these kind of projects. Any questions on this, like so how the students can be you know achieve from these technologies, like and actually I'd put in some slides for like if any of the students or anyone who would be interested to develop these kind of projects, like so they can use a software or development setup. There is something called Anaconda, right? Like it's an open source framework or the distribution tool, like so if they wanted to implement this data analytics, then they can install Anaconda, set up Anaconda on their machines. Anaconda, like so when they install, like it comes up with multiple tools, libraries, and also like IDEs like Jupyter and Spider. So this is how, like this is the Anaconda navigator. So Spider is an IDE, right? Like so in fact there is another IDE called PyCharm, right? Like so which can be used, like it's a very good tool. And that Spider can also be integrated into PyCharm, right? Like so these are some of the and when somebody is installing this, it installs all the libraries that are required for the development. You don't have to explicitly download each and every library. And there is another tool called Conda repository, like so this is also one of the things that has to be installed along with Anaconda. It helps us installing the libraries very easily, right? So it comes with every whatever type of project you wanted to implement, like so it downloads the required libraries for that particular project very easily. So these are some of the commands that I had mentioned here, like so what kind of I mean, it's just like very high level commands, right? Like so, and the Anaconda can be downloaded from this site. Like Anaconda, and like so if you just Google it, like you will get, like there are, it's available for different operating systems, like so Windows or Mac or Unix or whatever, right? Like so the libraries, I mean, like the installation is available for every other operating system. Any questions so far? I think I'm pretty much covered.
Any queries from the participants? Participants, any queries from your side? I think everybody is clear, sir.
Yeah. Okay. Okay.
So if we have finished, means can you wind up, sir?
Yeah, sure. I'm done with the session.
Okay, sir. So thank you very much for the wonderful sessions from the industry point of view on big data. So without much delay, let me invite Nibin sir for the vote of thanks.
Okay. Thank you, Mr. Balaji Sekaran, for your wonderful session. And your session on big data, data analytics, big data storage, machine learning, etc. was very informative. And I'm pretty sure that all the participants are very much benefited by this session. So on behalf of the entire mechanical engineering department of Vishwajyoti College of Engineering, I extend my wholehearted thanks to you, sir. And I also thank all the participants for attending this session. Thank you all.